particular episode of the GCSE revision series will be on algebraic proof. If you're catching this on YouTube, I'd appreciate it if you could click that subscribe button and click the like button, and if you would like to make comments on the video, please do so by leaving your comments in the comments section below. If you're watching this on Twitch, you can leave any comments that you'd like to make on the chat box, which you'll find next to where this video is playing. Okay, so this particular series of videos is really for GCSE mathematics, students doing GCSE mathematics in the summer. It's particularly suited to those who just want to go through past paper questions. If you'd like to see these particular topics from scratch, there are plenty of YouTube videos out there for that. You just need to go onto YouTube and you'll find them very easily. But these are really about exam questions, and as I mentioned earlier, this particular episode of my GCSE revision series is on algebraic proof. So, very quickly, we've got here a question on consecutive whole numbers. Before we kind of start, there's two little things that I'd like to show you just to make sure that you're clear on them. So I'll just take that question away just very briefly to show you just a couple of things. So the first thing is this: you do need to know for the conversations or questions on algebraic proof about odd and even numbers. So a general form of an even number is anything that has double n. So if n is any sort of number at random, if you double it, if you put 2 times that number, that's going to be an even number because it's a multiple of 2. And any odd number is 2n plus 1. So any even number plus 1 in general will be an odd number. So these are the two general phrases you need for these questions. The even number phrase, the 2n, and the odd number phrase, the 2n plus 1, because the questions often lean on your knowledge of odd and even numbers. And we'll do those questions in this particular video towards the end. We'll start off with some relatively simple ones and we'll work our way up. So this one here is talking about 3 consecutive whole numbers. So we can call those consecutive whole numbers n plus 1 and n plus 2. So n, the next one on, n plus 1, and the next one on again, n plus 2. And it says, prove algebraically that the largest number and the smallest number are factors of the number that is 1 less than the square of the middle number. So let's look at that last part again. It's got to be 1 less than the square of the middle number. So our middle number here is n plus 1. We're going to square that up, so n plus 1 squared. We're going to do that using our brackets work that we've done, and if you want to check out my video on expanding brackets, you can see me working my way through these. So n plus 1 all squared, that's n squared plus 2n plus 1, when you multiply these things out. And we need to do 1 less, because it says 1 less than the square root of the middle number. So 1 less than that, so n plus 1 all squared take away 1 is just this, n squared plus 2n. So n squared plus 2n, which is this, take away the 1. Now, it's saying, prove that the smallest number is factors. If we factorise this, take out n as common, you can see that you're going to have n and n plus 2, and lo and behold, that is my first number and my last number. So n and n plus 2, my first number and my last number. So that has shown that my factors are n and n plus 2. So we're going to put the 2 lines to show as proved. Turning it over, we can see this particular question. This is looking at the difference between the squares of any 2 consecutive integers equal to some of these 2 integers. I mean, the way these questions are worded, they're really wordy questions. You just got to step your way through it really carefully. Take your time. They do cause panic, but it's important just to take your time through it, understand what's going on. So we'll focus in on where it says 2 consecutive integers first of all. So we're going to start with 2 integers, n and n plus 1, and that's what I would encourage you do. Just focus in on where it says consecutive integers. Just write down that you've got 2 numbers, n and plus 1. The previous question we focused in on consecutive whole numbers. I wrote n plus 1, n plus 2 straight away. So all the time, try and focus in on that word consecutive. If you see that, that's where you should start the question. So n and n plus 1, they're my consecutive integers. Now let's look at else what it says. It says the difference between the squares of any 2 consecutive integers. So what are the squares of these numbers? Well, the square of this number is n squared. square of this number is n plus 1 all squared. Again, common error, people just go n squared plus 1, but it's not. It's n plus 1 all squared. That's with your pair of brackets, n plus 1, n plus 1. If you do enough of these questions, you'll get used to these. They're very, very simple when you get used to them, and they're very similar as well. Now this is asking for the difference between those things, the difference between this and this. And we know the difference between those two things would mean take them away. So we're going to take the two numbers there, n squared plus 2n plus 1, there's that bit, and then take away the n squared, this bit over here. So you can see n squared minus n squared, they're going to cancel out, leaving me with 2n plus 1. So that's an odd number, isn't it, based on the stuff we learned a minute ago. But it's saying, is it equal to the sum of the two integers? So is this 2n plus 1 equal to these two things added up? Well, it is, yes. You can see that this is n plus 1. That's the same thing as that, and so we've shown it. And so that's what you say as proved there, to show that this is n, and then plus n plus 1 to show that these two things are similar. And you might just want to emphasise that by putting these two things in brackets to show that they're the same thing all the way through. Okay, moving on. This one here a little bit more difficult still, so cranking up the difficulty just a little bit. So this is saying prove that 2n plus 3 all squared minus 2n minus 3 all squared is a multiple of 8. So you've got to show that that minus this is a multiple of 8. So let's look at this first. So 2n plus 3 all squared. I think you probably would like these better because they're a little bit more descriptive. So you can see quite quickly where you're going with this. You have to be good at multiplying out brackets, so start to be a bit more adept at working out things. You'll see. Be careful with the plus 9 here at the end. Minus 3 squared is plus 9, so minus 3 times minus 3 is plus 9. Just in case you don't know how I'm doing this, I'm thinking in my mind about this. And similarly 2n minus 3, 2n minus 3, so that's how I'm doing these two things. Now they're saying that this, take away that, so it's this, take away this, so we're going to have 4n squared plus 12n plus 9, take away 4n squared minus 12n plus 9, 9 minus 9 is 0, 12 minus 12, so 12 minus minus 12, 2 minuses make a plus, 24, and 4n squared minus 4n squared is, excuse me, is 0, so we're ending up with 24n. Now, is that a multiple of 8? Yes, it is, because it's 8 times 3n. Oh, sorry, I'm a bit too low to show that, sorry. So I'll just do that one more time. So set it out like a sum. 9 take away 9, 0. 12n minus 12n, so 2 minuses make a plus. So that makes 24n, and then 4n squared minus 4n squared is 0. So is 24n a multiple of 8? Yes, it is, because it's 8 times 3n. And that then means that this is a multiple of 8, because you can see that it's a multiple of 8. So we just put multiple of 8 and then just put the two lines to show that we've proved that. Very straightforward, not hard. This next bit, question 4 here. So again, looks like a whole load of stuff that we've got to multiply up. So it's got to be good at multiplying up brackets. So again, if you step your way through these things, these should be very simple. Make sure you don't make the common error, which is to say that 1 squared is 2. That's very common. Obviously, 1 squared is 1. And then we've got n squared plus 2n plus 1 over here. And I'm going to show these two things added with this one in the middle. So n squared minus 2n plus 1 plus n squared from up there. And then this here, so n squared plus 2n plus 1. And then we've got 1, 2, 3n squared, and you've got minus 2n plus 2n, that cancels out, and you've got 1 plus 1, that makes 2, so it is saying it's the same thing as that. So we've shown it. It's nice and easy to do. Okay, moving on, this one here. So the product of two consecutive positive, remember, hone in on that consecutive word, two consecutive positive integers. Before we even go anywhere further, I'm going to write two consecutive positive integers down. They're saying a product of two consecutive positive integers added to the larger of the two integers. So what does product mean? Product means multiply these things up. So if we multiply those things up, you'll get n squared plus n. So we know that straight away. And they're saying add that to the larger of the two integers. The larger of the two integers is this one. So n squared plus n, the product of these two things, plus the larger of the two integers, which is n plus 1. If you do that, you get n squared plus 2n plus 1. And they're saying prove that the result is always a square number. Well, if you factorise this, you can see this is n plus 1 all squared. So that is showing that it's always a square number. So you've shown it. You do have to write a little bit of explanation in general. Just make sure that you've got that. And I will just show the examiner that I've added these things up to get to n plus 1 here. And then also, oh, sorry, I do apologise. I need to show the product. So n times n plus 1 was n squared plus n. So that's where that comes from. So I will just show that, just to make sure they know where I got it from. Okay, straightforward, not a problem. This one here, so this looks a bit more difficult. Again, just to crank up difficulty as we go. So this is a half, lots of horrible brackets and stuff to multiply. So if we ignore the half for now, because that can throw people, just do the brackets. So n squared plus n, straightforward. And then again, the brackets here, n squared plus 3n plus 2, if you multiply those out correctly. Then put the half next to it at the end. So that's the easiest hint I can tell you, is just try to work with the brackets bit first and stick the half bit in the end. We're adding these up because it says sum, and it's asking you to find that it's always a square number. So again, you've got half n squared plus a half n squared, that's 1n squared, and you've got a half n plus 3 over 2, it's 1.5, 1.5 plus a half, that's 2n, and then you've got this half of 2 at the end, so plus 1, so it's exactly the same as the previous question. It's just n plus 1 all squared, so that is always a square number, and so we've shown it, and that's not a problem. Easy. This next one was a misprint, so I've corrected it slightly. I'll just explain what it's saying. So this is one that's using even numbers, so that's important, and this is 2n plus 1 all squared. So 2n plus 1 all squared minus 2n plus 1, you've got to show it's always an even number. So the first set of brackets we multiply out, so 2n plus 1 all squared, and again I'm going to show the examiner what I'm doing. So that's what you get when you multiply that out. We're going to take that away. We're going to take 2n plus 1 away from that. So 4n squared just stays as it is, but 4n take away 2n is plus 2n, and then plus 1 minus 1 that goes away at 0, and then 4n squared plus 2n, what's that? That's going to be two lots of, if you take out what's common, it's two lots of this. So 2n times 2n plus 1, and again, this is most definitely an even number because it's got the factor of 2 at the beginning. So you can say it's got the factor of 2 at the beginning, so it's an even number, as shown. I was going to get that squared off of the camera for you a little bit. So this one here, again, hone in where it says consecutive. This one's talking about odd numbers, so we can use our information from earlier. So that's the first odd number. The next odd number will be 2 on from that, won't it? Because let's say you had 3, the next one will be 5, so it's 2 more further on, so 4, 5, and then the next one on from that will be 2n plus 3, 2n plus 3 is the next one on, because it's 2 on from there, and then 2n plus 5, so 2n from there again. So, sorry, I apologise, so it's 3, and then 5, and then a 7, for example. You'd start with 3, and then 2 more further to get the 5, and then 2 more further to get the 7. So the 3 consecutive odd numbers would be 2n plus 1, 2n plus 3, and 2n plus 5. So you have to think about the consecutive odd numbers here. You're looking at the squares of them, and you're looking at the sum of those squares. So we're going to multiply the squares up first of all. This will be worth quite a lot of marks, I'd imagine. So work your way through that. And then 2n plus 5 all squared. Plus 25, that's fine. It's going to do some bit of checking because I rushed through that a little bit to make sure it's all okay. I think that looks think it looks fine. So you need to add those up now. So we're going to do 4 plus 4 plus 4, that's 12n squared. And then 4 plus 12 is 16, 16 plus 20 is 36n. And then 1 plus 9 is 10, and then 10 plus 25 is 35. So that's what you get when you add it up. So that's the sum of the squares. Now they're saying it's always 11 more than a multiple of 12. So if we take 11 away, or think about separating out 11, this would be 24 plus 11 at the end. So if we think about that, can we say that these are multiples of 12? Well, yes, that's a multiple of 12. Yes, that's a multiple of 12. And yes, that's a multiple of 12. And then you've got the add 11 on the end. So you just have to say that you've got a multiple of 12 plus 11 as shown. So that's not a problem. If you want to go an extra step, you could show that 12 is a factor, just to cover it off, to make sure they don't take any marks off you. I think that probably would be safest, to show that that's a multiple of 12. So that's a multiple of 12, and then you've got the add 11 on the end. So not a problem at all, very easy to do once you get there. This last question is probably one of the harder questions I could find on algebraic proof. Not an easy one at all to think about, but once you get the gist of it, it's okay. So it says A, B, C are positive integers such that A is more than B is more than C. It says n is the largest three-digit number that has the digits A, B, and C. So if this is the largest one, then you're going to have A in the hundreds column, B in the tens column, and C in the ones column. And then similarly in the K, the smallest number, is going to be the other way around. So C is going to be in the hundreds column, B is going to be in the tens column, and A in the ones column. And it's saying show the difference between n and k is always a multiple. So the numbers, their value, the digits, the value that they are, is going to be 100a plus 10b plus c. So because the a is in the hundreds column, you're going to have the value of that number will be a hundreds, b tens, and c units, c ones, sorry. Take away, again, you're going to have 100c, and then again another 10b, and then another a on the end. So you've got all these things. That's what you're going to do because you're looking at difference. So 100a minus a is 99a, and then 10b take away 10b, well, that's going to cancel. And then c minus 100c is minus 99c, and that is a multiple of 99. So you have shown that it's always a multiple of 99. Okay, I think that will do it for this particular video on algebraic proof. I hope that was useful for you. If you'd like to click the like button on subscribe, please do go ahead and do that. If you'd like to make suggestions of further videos, please do so in the comment section below. I do wish you all the best of luck for your exams in the summer, and I'll see you soon. Goodbye.